Okay, bismillahirrahmanirrahim. Assalamualaikum warahmatullahi ta'ala wabarakatuh. Okay, so today we are going to move to another chapter of our data structure, which is we have Q. Okay, so basically once we call a Q, so in Malay, so biasa kita sebut Q ni beratur, right? Q. So for this data structure, so we implemented how we can describe. We have this queue in our computer. How we arrange our data menggunakan konsep beratur or queue ni lah. Okay. So, okay, queue is a collection of items in which insertion take place at the end of queue and deletion take place at the front of queue. Okay, queue ni adalah bila kita masukkan data, so dalam kita punya komputer, dalam kita punya storage, computer storage tu, so dia akan letak insertion akan duduk belakang sekali, and once we want to delete that particular data, dia akan delete yang paling depan sekali. Okay, queues are used to simulate or deal with list of object where the first object to go in is the first to come out. So dia menggunakan analogy first in, first out. Okay, this behavior is known as first in, first out lah, FIFO ni. Okay, so kalau data tu masuk dulu ke dalam kita punya computer or storage, dia kita akan remove dulu. That's why we call it as queue data structure, because once you queue, you beratur panjang-panjang, siapa yang akan leave the queue itself? Mesti orang yang mula-mula beratur yang kat depan tadi kan. Okay, same goes to this lah. Okay. So we can see that this is an example of real life queue. Okay, the simplest one is queuing in bank. Okay, services the first person at the beginning of the line. This one is the first person dekat kita punya barisan ni. And leave. Okay, leave. Dia akan serve yang ni dulu. Contoh nak queue dekat bank, nak withdraw duit. So it means that the first person will be served first, then dia akan leave the queue. Okay, then others join at the end must queue until they move to the front. So kalau lah dia nak ambil duit and if let's say that the other person that want to withdraw the money, so he or she need to queue at the end of this queue lah. Kena masuk dalam barisan, kena duduk belakang sekali. Then he or she will be served, okay, bila dia dah sampai dekat depan ni. Okay, so that's why we call it as first in, first out. First yang masuk ke dalam into this queue, so dia akan mula-mula keluar daripada queue lah. Okay. Okay, so let's talk about this data structure. Queue can be implemented using linked list or sequential list. So in reality, once we are talking about queue data structure, so kita boleh implement dia based on linked list or sequential list. Okay, since we know that if we want to implement queue using linked list, so means that we need to implement it using node. Ingat tak? Sebab linked list kan kita implement menggunakan node, right? Okay, then if we want to implement queue using sequential list or array list, so we need to implement it using array. Okay, sebab apa? Sebab sequential list or array list is implemented using array. Okay, so in this course, self-defined class queue is using a constrained version of a singly linked list, which is new node can be added and at the end of the list and remove from the front of the list. Okay, so untuk subjek kita ni Csc 248, what we are going to have is we going to implement, since we know that we have two types of linked list, three types of linked list, singly, doubly, and circularly linked list, right? But for this version, for this course, we're gonna use a singly linked list, okay, which is what we can have is new node kita akan add ke dalam kita punya list. Okay, new node yang kita akan add tu ke dalam kita punya list, dia akan pergi kita add dekat depan sekali. Dekat belakang sekali. Lepas tu bila kita nak remove, kita akan remove node yang paling depan. Okay, so kita akan remove node yang paling depan. Kalau nak add, kita akan add and letakkan dia dekat at the end of the list. Okay, using linked list structure. Kalau kita implement Q menggunakan linked list structure, which is dia akan implement dynamic data structure where elements are stored anywhere in our memory. Sebab bila kita menggunakan linked list, dia menggunakan konsep asal, the linked list itself, which is the data or the node can be located anywhere in computer memory. But how we can know that this one is our first node and second node? So we are using pointer, right? Okay. So we have many applications in nowadays, using this Q data structure. For example, we have this pooling in printing, supports pooling in printing. If you notice once you want to print many documents in a time, okay, you click a few document untuk nak print. Okay, kalau you perasan dia akan ada keluar bar macam dia akan keluar interface macam ni. So dia akan display all the document that you want to print, but we can see that dia ikut turutan macam ni lah. So yang mana you klik dulu tu yang dia akan print dulu. Okay, first come first lah. Okay, so single printer shared by all users in a network. Okay, each printing job are placed in a queue until printer becomes available. Okay, tak kira lah kalau you guna sebagai standalone computer ke ataupun we are using network computer ke kan. Network computer, you can just imagine that you duduk dekat dalam satu lab, you are sharing one printer among many computers in a lab. So means that all that computers or client computers in a lab are sharing the same printer. So you can just imagine that all those clients, okay, all those client or PC dekat lab tu dia hantar dokumen ataupun send print to nak print document to that printer. Printer tu ada satu je kan. So ada contoh for it. We have up to 10 computer that need to print the document, right? So daripada 10 tu, so dia nak print yang mana dulu. So dia akan tengok lah, dia akan masukkan dalam list macam ni lah, lebih kurang macam ni. So yang mana masuk di first in, dia akan serve dululah, dia akan print dulu sampai at the end of the list. Okay, another example is computer with single processor. Okay, only one application can be serviced at a time. Each application requires processor to be placed in a queue. Okay, so macam nowadays we have multiple processors for our computers, right? But kalau komputer dulu-dulu, so untuk satu komputer dia ada satu processor sahaja. So kalau if you want to run many program, so dia kena program tu in a time we can only run a program or one application sahaja. Okay, so dia kena ikut turutan lah yang mana. Kalau nak print, lepas tu nak dengar lagu, so dia kena print dulu, baru lepas tu dia boleh dengar lagu lah. Itu dulu punya komputer lah, single processor. Okay, so information in computer packet, computer networks. Okay, routing nodes send one packet at a time and must be in queue. So data yang kita nak hantar menggunakan internet, so dia akan menggunakan packet. Okay, packet-packet tu akan dihantar based on a queue punya structure. Means that yang mana yang dihantar, yang mana that need to be sent to the receiver, okay, akan pergi hantar dulu. So yang belakang akan mengikuti lah. Okay, next is file server in a network. File access request from client are placed in a queue. So all are these the application of queue in computing lah.